Okay.
Okay, does everybody see a star field?
Yep.
We
All
do.
right. I was going to present Starry Night Pro, but when I went to look on the website to see if there was an updated version, the Starry Night program is no longer available. So I thought, that's not a real good thing. So I've been playing lately with delirium. I find its interface fairly easy. There are a few things that I enjoy, particularly that you can actually get an idea, at least for a DSLR, what your field of view is going to be. There are a number of very simple controls. They're easy to use. Over on the left side of the screen, you'll see kind of the standard controls. So you have your location window, which you can set. So again, this being a program that's both available on your pad or your PC or your Macintosh, you can port it with you. So it's nice to be able to say, well, I'm not in Tucson anymore. I'm up in Phoenix, or geez, I'm in Flagstaff. So this really helps. You can actually set where you're at. Then you have a sky view, and that allows you to do selective identification. Um, Unlike a lot of people, I don't like to see all kinds of artistic images for the constellations on my screen. I tend to do the stereographic imaging with the asterisms, and that is easier for me to recognize things in the sky. You can change how you show the planets. You can do orbits. Um, you can have 3D models. There's a lot of selection capabilities here. Again, I like to keep them at a minimum, use as little bit as possible. My favorites on the dark deep sky objects are M, NGC, IC. I also like to look at SH2, and we can use those labels, and those will show up on the background and screen. Under markings, you can change the colors that you want. So you have a lot of options here in the celestial period. You can put up an equatorial grid if you want. Elliptic grid, sometimes those are really good to have, particularly if you're going to be imaging along the elliptic. So a number of different things that you can put on the screen to help you. As you can see, the screen starts to get pretty busy when you do a lot of this stuff. So I don't generally do too much on this one. Whoops, I didn't finish up there. Landscape, you always have a choice. You can show the ground. You can take the ground off. You have a few different choices. I just used this one. It gives you kind of a flat reference. I do like to know where the horizon is. This particular program will put the horizon there, and you can see it quite easily. So you can see down here we have a horizon now. Our asterisms are in place. We're looking south. One thing that I really don't like about this program is that it always starts up pointing south. Um, I choose really to point north as my beginning. That's kind of how I set my telescope up, so it's kind of a default for me. But it's really easy. You can just rotate this thing around and go straight to north. So it's pretty easy to move. You just click and grab and move it over. Um, I think that pretty much covers everything on that particular. You have a search window just like anything else. Um, One of the things I'm not real good directionally. I like to know where the moon is. Well, right now, it's right there. It's in the northeast. So all of these lovely objects that I would like to image maybe are going to be definitely affected by the moon. So I use this in that format. It makes it a lot easier to know. Well, maybe I don't want to be imaging Orion tonight, but if I go over here to the north, there's a bunch of stuff that the moon is behind me pretty much, and I can do some imaging to the north. The search function's fairly powerful. I haven't tried it on specific stars or specific locations, but there is, let's see, under tools. Um, Object information. You can really get a whole lot of information. I prefer the short information. Um, Additional settings, asterisms. Here's where you can set your asterism lines, your labels. A cardinal point, you can put it in night mode. There's a centering button. You can actually center something on the screen if you want. And usually this is the standard or the defaults. I usually leave that. Time. The other thing that's really nice about this program, you can actually change the dates and time. So let's say tonight is not a night you're going to image, but you want to image, let's say a week from now. So you can actually go to the date and time, this one right here, bring that up, and then you can just simply go 1, 2, 3, 4, 5, 6, 7. Okay, 7 days from now, same basic time, and you can then see where these things are in the sky. We can go back and we can search for the moon again. Oh, well, that's nice. It's not up yet. And it'll drive you. And so if you see the asterism going away when you've told it to go look for the moon or objects below the horizon, um, it drives everything off of the grid. So I found that to be useful. Let's go back to today. A couple of the other nice features, you can set. So if you were going to do visual observing and you wanted to know whether or not a 40 millimeter lens on your Celestron C8, as you can see up in the left-hand corner, you can select the telescope, you can select a number of different eyepieces, you can actually select the camera. So there's a lens, a focal reducer I have, because a lot of times when I'm imaging with the C8, I use a focal reducer. You can do a 3x Barlow, a 2x Barlow, or no lens other than the 40 millimeter Plossl that you're using. So that's kind of handy, particularly if you're doing visual observing. The other thing is rather neat with this program is it has a number of sensors that you can select, and it'll draw a little red box that is equivalent to the field of view of the sensor. So as you can see, the field of view for that particular sensor, which is an EOS 450D APS-C, is giving you roughly 37.56 arc minutes by 25.04 arc minutes. And that's really nice, particularly if you want to look at a lot of different things. Let's pick something here. So let's pick on the Christmas tree cluster. And we'll zoom in. And you can see what that particular field of view will look like. And you can move that around a little bit to kind of see how you might want to organize this in your field of view when you're taking your image, so that you get most of the things that you'd really like to have in your image. And that's been really handy for me because a lot of times in the past I've taken images, and what happens then is, darn, if I'd moved over just a little bit, I would have got that globular cluster in the image with my nebula. And this kind of helps me really do that. And I'm using a mouse with a thumb wheel, so I can move back and forth with this really easy. I can move the whole sky around, pick on a different object, zoom it in, zoom it back out. So for that kind of things is the way I would use this program. This program can control your telescope, can do do the movement and the control of the telescope. I do not use it that way. I use it for these kind of things. And I'll open the floor to questions. So if you have questions, let me know.
Hey, Tom, it's Randy. I use delirium for all of my planning, plan even a month ahead what I want to shoot and the time, and the oculars set up there. I have each of my cameras, each of my scopes, everything is set up there. And so I can just, once I go to an object, I can toggle back and forth from one scope to another, or a reducer or no reducer. And you can easily see there. And then you can also adjust, you can rotate the framing so that when you go out there, as you say, how much will fit in your frame and the optimum angle that you need to have your camera to do it.
Right.
So it's very helpful. But if you go one more click, well, let's see, if you bring up the oculars, it has lots of pre-programmed, mainly 2 more clicks to the right, up on the top there. One to the left of that.
Here we
there you go.
Okay.
And you can change the angle of your view, so you can know how you need to frame something. And I have, as I say, all of my stuff is programmed in, so I can toggle from one camera to another, or one sensor to another for size. And I can go to the Red Cat or the C11, I can go to the C11 with the reducer or without the reducer, and you get everything set up in there. And if it's not available to select, you just enter the information for the sensor size. Anyway, it's very helpful, and
Yeah,
it's my primary planning tool.
that's kind of the way I'm using it, is as a planning tool. I like that I can move the dates forward, ahead, to see where the object is, in my field of view, because some of the stuff to the south, my house is to the south of me, and there's a lot of stuff, unless I go into the backyard, that I can't see. So yeah, I use this pretty much the same way you do, as a planning tool. And I've really, I haven't gotten to a point where I can put my ASI Air 533 in, my ASI Air 294, and those things yet. But I was getting there, just haven't quite got that far yet.
If you'll just go to the ocular menu, then you can set up everything. And once you set it up, it's there, and it'll always be there every time you start the program.
That's cool. Thank you.
So one other thing with the planning portion of it, actually you can put in a custom horizon. So if you have the ability to take a panoramic picture or a 360-degree picture, like me, I live in Sahuarita, so I'm a Bortle 3 down there, so I image from my backyard. I have no light pollution around me. So I could take a picture of my backyard where my telescope sits, and a 360 view around it. And then you can put that custom image into Stellarium, and it will have your house, the trees maybe around you. So you can see if an object will be behind trees or it's behind your house. For me, I'm imaging M31 tonight, and that will end up going over my house. But if I was to put in that custom horizon, I could see what time it's going to go behind my house. And then I know in my ASI Pro, I can tell it, hey, at this time, switch to a different target because it's going to be behind the house.
Yep, that's pretty cool. It's a very flexible and extremely powerful program, and it's free.
Yeah, another feature is you could set up for off-axis guiding. You can add the prism size and then your guide camera and also the rotation. And in your planning, if you're using an off-axis guider, you can if you're working with an angle, say you're like at 60 degrees, and you see what potential guide stars you have available. So that's fun to play with too.
Yeah.
There's also a mobile app. You can get it on your phone too.
Oh, that's nice.
So maybe I'll just jump in with a couple comments as well. I use it for planning, and I think there's a couple features that you didn't mention that I find really interesting. So I always keep the alt as grid on because I want to know what the altitude of the targets are usually that I'm chasing. I always keep a meridian line on, which you can select, and there's a little angle viewer tool at the bottom. If you look at the bottom, you showed the left-hand tool menu. There's a bottom menu as well, and there's something that looks like a little protractor down there. And if you want to know, for instance, how far away the moon is from your target or whatever, you can just click on that sign, and anywhere you draw in the GUI, it'll stretch a line out and tell you how many degrees away you are from that object. And then when you're done with that, you can either keep selecting objects, or you can just go down and reselect the protractor and get rid of that. And I typically keep the date and time function up. I keep it up all the time. I never turn it off. So when I come into Stellarium, I put that date and time thing in the bottom right-hand corner, and it sits there all night because I'm constantly asking myself, okay, well, how much longer can I view this target before it crosses the meridian or whatever, right? So
Yeah.
But those are a couple tools that I think are pretty nice. That angle measure is a nice little tool.
Yeah, one of the nice things about my ASI Air is it will give me a warning if I set it up properly. Say, 5 minutes from now, we're going to cross meridian. And I can, set it up for doing the meridian flip whenever I want. So the ASI does that also, which is kind of cool when I'm imaging, to be able to know whenever you start your imaging process, it'll tell you that you're 50 minutes from the meridian, you're an hour from the meridian, you're 2 minutes from the meridian, whatever.
The last thing I'll mention is that there are add-ons. There are a bunch of add-ons that you can add to this. So extra star catalogs, there are a series of extra star catalogs you can add on. There's some DSOs that you can add in as well. There's a bunch of little add-ons that come, and there's a menu for that. You can go and you can just look at the add-on menus and start clicking them to add functions in here. So it's actually a pretty nice little tool. I've been using Stellarium for many years.
Wonderful. I'm going to pass it back to you, Greg.
Okay. And I'm going to reiterate a lot of the stuff that Tom talked about already. I use a really old program that's not available any longer, but I think some of the functions that Tom has already talked about are present here as well. And I'm just going to give you a rundown of some of the very specialized areas that I use. This is called SkyMap Pro, and I think it went out of publication back in the early part of the current century, around 2005, but I've been using it for over 20 years. And listed on the side here are the things that most of these planetarium programs do. And these are the things that you probably need to be interested in if you're going to use some sort of a planetarium program, whether it's Stellarium or the Sky or one of the older programs. But for example, plotting stars, tracking comets, asteroids, and satellites, if that's your thing. As you know, I do a lot of comet imaging, and so it's important to me to have something where I can upload the ephemerides for the latest comets and have those plotted out, and this old program does that pretty well. It also does things like allow you to list eclipses, what their visibility is from various different places on the planet. Of course, most of these planetarium programs have all of the basic catalogs in it, and SkyMap has that for the Messier, NGC, AISIG catalogs. It also includes images for all of those things, similar to what you saw for Stellarium, although in this case you have to click on the object to actually bring up the image. So it doesn't automatically appear unless you want it to. It also has the ability to have you set up your own catalog. So if someone publishes a catalog that isn't contained, it has tools that allow you to put the appropriate data in so that those newly defined objects can be found as well. And one of the important things for me is that even though it's over 20 years old, way back then it supported ASCOM telescope control. So in addition to using the program for planning, I also use it to control my telescope. And it does that fairly well using the ASCOM interface. And like the Stellarium program, you can define your own camera, binocular, finder fields, as well as the user-defined horizon. So I'll just show you a couple of those things. If I can get it to go to the next screen. So again, it shows you a solid horizon for where you're located. And then you can see here, there's a yellow line that's put in because I've entered the coordinates at 10-degree increments for the roof line of my roll-off roof observatory. So I can look at the image quite easily, in this case, looking east, and see whether or not a particular object is going to be above the roof line so it can be imaged at a certain time. So again, having the ability to put in a custom horizon makes the program even more functional. And as you can see, it does the typical outlining of the constellations, et cetera, locating the moon, comets, et cetera. If you zoom in, all of target things that you have listed that you check off, just like Tom showed in Stellarium, will show up depending on their magnitude. So again, all you have to do is click on one of these to bring up additional information, or if you have the telescope connected, right click on it and say slew here, and the telescope goes right to that particular object. And again, I use that for pointing the telescope as well as planning. I also use the customized camera sensor size. So I have a full frame camera, but I don't use the full frame sensor all the time. So what I've done is defined a 50% of full frame sensor. And this is the built-in guide camera, the guide chip, which I don't use. But it allows me to use either the 50% full frame, a 75%, or the full frame. And I can simply decide which of those is the most appropriate for composing the particular target. So just as Tom and Randy described for Stellarium, having the ability to have customized frames like this that are consistent with your optical setup make it very convenient to frame the target that you want and to make sure that it's composed in a way that all of the detail that you want to be in the image shows up there. And again, by double clicking on the target, you bring up the associated image. So as I said, I do a lot of comet imaging, and SkyMap allows you to put in not only the object, but to put in the track of the object. So for example, here's Comet Leonard from a few weeks back, and you pull up the track object dialog, and you can put in the time that you want to observe, the map time, and then the calculation interval and how many positions you want. So what I typically do is put in a 1 hour calculation interval and then calculate 3 to 5 positions and mark those positions with the time every position. And that shows me what the comet is going to do over the next couple of hours, or over the couple of hours window that I have when I'm proposing to image that particular moving object. So the way that shows up, and you may remember at the last meeting, I showed an image of how Comet Leonard was going to pass between the Whale Galaxy and the Hockey Stick Galaxy. And again, I generated this using the SkyMap track object protocol, simply by putting in the date and time and telling it to show me the positions in 2 hour increments of where the comet would be, so that I could pick out at what point I wanted to begin and end my imaging run. So again, I don't know, I imagine Stellarium has a function to do that. Most of the commercially available programs have something along those lines, but I find that extremely helpful. In addition to plotting out the position of the moving object, the comet in this case, I usually also print out a hard copy of that particular frame. And this goes in my observing log or my imaging log, along with the regular log entries. And you can see here, I've used this as a scratch sheet, so that once I have the position laid out and have an idea of when I'm going to image the object, then I can go ahead and calculate how far the object is going to move every minute and compare that to my pixel resolution to see whether or not I need to have a longer or a shorter. And you can see here, I was kind of mentally thinking about doing 2 minute versus 1 minute integrations as the comet moved between these two galaxies, and then deciding how many total images I needed. So I found it very helpful to print out some of these descriptions, so that I can then use that either at the telescope or later on when I'm trying to actually do the pointing. And again, because the printout contains the right ascension and declination of the very center of the field, I can use that to go back to the same exact location night after night if it's a target that I want to image on multiple occasions. And so this is what I used in order to get the image that I posted of the comet passing between those two galaxies. So I'll stop at that time and see if there are any questions regarding any of those particular approaches.
Hey, Greg, Terry wants to know if that program runs on Windows 10.
It does. It's a old 32-bit program, but if it comes on a CD, and if you copy everything on the CD to a folder on your computer, and then just link to the executable, it runs just fine, and that's how I've been running it for the last 20 years. So unfortunately, you can't find it any longer, although there are some places online that say you can download it for $99, but I checked a few of them today and none of them seem to work. So unfortunately, it's a out-of-date program, but the techniques that are there, I think, are things that can be used with some of the currently available programs, especially if you can find one like Stellarium that's free.
All right, thanks. I had the program. I loved it, but I never tried it on Windows 10. So I appreciate it. Thanks.
Yeah, all you have to do is copy the contents of the CD to a folder, and I actually put it in the root drive on my Windows 10 laptop and desktop, and then copy the file. The images are on a separate CD, and you can copy those to wherever you want them as well, and then set it up that way. So it's still usable.
Thanks.
All right. Who would like to go next? Has anybody else got another program that they use that we haven't discussed yet?
I can't really share my screen. I'm actually sitting outside of work right now.
Okay.
But I do use, for my planning, if I want a quick look, I will pull up Stellarium on my phone because it has a mobile app. But for me, I use Telescopius, and I think it's astronomy.tools. Yeah, astronomy.tools and Telescopius, because Telescopius will tell you essentially you can search through it and find objects in the sky that are, I used it the other night to find objects that are a certain degree away from the moon, because it's obviously hard to image anywhere near the moon. So then I'll switch to astronomy.tools, and that has not only the FOV calculator, it has the, for me, I use, it'll give you basically if you are undersampling or oversampling, or you got good sampling with your camera and your telescope combination, because you don't want to put a huge camera on a small or a super long telescope and end up oversampling. So astronomy.tools is really good for FOV calculator. If you're looking to purchase a telescope or you're looking to purchase a new camera, you can put in all the information for your camera, your telescope, figure out if you're going to be undersampled, oversampled, and then all my planning, mostly I use Telescopius for.
Those are good online tools. Another good online tool, particularly if you're looking for comets, is Heavens Above, because they usually have most of the currently visible comets, as well as you can click on them and they'll give you finder charts to help you point your scope in the right direction. So that's a very useful tool as well, as long as you have internet access where you need it. Any others? No. Okay, well, I have a couple of announcements we need to go over. One is that, as Tom and I have mentioned previously, these meetings will occur for the next foreseeable future on the third Monday of the month. And we'll continue to have our Zoom meetings. And Wendy has assured me that the address will remain the same. So if you have the address for tonight's meeting, theoretically, you should be able to click on that on the third Monday of the month at 7 o'clock in the evening, and it will bring you back to this same place. So keep that in your calendar for future reference. If you'll recall, back in May of last year, I brought up the issue of sharing images with the Desert Sky Bulletin that the TAAA publishes every month. And David Rossiter, the editor of that, was excited to get those images and is still wants to have those images. But rather than doing it in a piecemeal fashion, we thought that we would do it in a little bit more organized fashion. And that's to make sure that if the image that you would like to share, you really want to share with those on the bulletin, that you send that image to me as a submission in the form of a JPEG file that's 10 megabytes or smaller. And so that will allow me to collect those and then send a selection of those to David every month for him to include in the newsletter. And a 10 megabyte or smaller should preserve enough resolution that when he reproduces it in the newsletter, that it appears appropriately. So again, if you would like to have your images shown to the rest of the folks who belong to the TAAA, all you need to do is send a copy to me and say, I'd like to submit this for the newsletter. It doesn't mean that you'll necessarily get it that month, but I collect them and then forward them to David. And that way we'll know that it's okay for you to do that. Some folks publish their pictures in other places. In other words, you may send it to Sky and Telescope, or you may want to send it to Astronomy magazine or some other publication that you want to keep it as a single submission. So I'm not just going to assume that because you shared it with us on the TAAA forum that it's free to use on the Desert Sky Bulletin. I'd ask you to submit it specifically for that. The other thing that will happen is if you submit that and I select it and send it on to David, David sends out a preview of the bulletin so that the contributors all have a chance to look at it. And so you'll get a copy of the bulletin a few days before he actually publishes it so that you can look through it, find your image, and make sure that it looks good to you. If something doesn't look right, or it's mislabeled, or it's upside down, you can reply back to David and he can fix it before the final version goes out. So it's important when you submit the image to me to make sure that you have the email address that you send it from is the one that we can contact you back so you can preview the image in the bulletin. And it's also a good idea that if you are publishing your image on a website or on AstroBin, please include the link to the image so that someone who sees your image in the Desert Sky Bulletin will also see the link to it so that they can go explore the image in greater detail, find the technical details if that's available, and enjoy the image even more. So that's going to be the way we'll do it going forward. If you have any questions about that, you can ask now, or if the questions come up later, feel free to contact me offline, and I'll try to reiterate all this. And I'll try to put all this in an email to the entire group so that everybody that's on the TAA forum is aware of how we're going to handle this in the future. Any questions?
Thanks for doing that, Greg.
Yeah, and I would encourage everybody to share your images. If you have an image that you're working on and it's got all kind of crazy stuff going on and you just want help, well, you don't have to submit that unless you want to. But if you've got an image that you're proud of and that you think you've done as good a job on as you can do or whatever, and you want to submit it, send it along because from the comments I've gotten back from David, and he hears a lot of comments back about the bulletin, the images that we've been posting are one of the highlights. So I'd like to do even more. So we've been doing 4 to 6 images every month, and we may increase that or we may decrease it depending on the number we have in the space. But I would encourage everybody to continue to share your images. And if you want to share them with folks on the bulletin, then just send a copy along to me.
Oh, okay. By the bulletin, do you mean the newsletter?
Yeah, the Desert Sky Bulletin. It's called
Okay.
Desert Sky Bulletin now.
Okay.
Yeah, it was the newsletter. Now they call it the bulletin.
Uh-huh. All right.
Yeah, Greg, are you saying that you prefer a separate email rather than including it when we post something to the TAA group?
Well, I know, Randy, you've been very good about including a JPEG with your postings. I would ask that you send a separate email.
That's
because
fine.
What I'll probably do is just collect those emails and then pass those along. And that way there's no chance that I can mess it up in the meanwhile. So
Okay.
yeah, if you would, when you post it to the TAA forum, and again, I encourage you to do that so this group can see what you're doing and enjoy those images. But yeah, send me a separate email to make sure that I know that it's okay for me to use it to send along for the bulletin.
Okay.
Anybody have any other questions or images that they'd like to share? We have a few minutes left in the
Okay.
hour.
I have some, I have a couple of images to show. Let's see, share screen. I've got one. These are my first images with my, taken with my 6-inch refractor. This is an Astrotech 6-inch refractor working at f6.4. I use with it a William Optics large reducing flattener lens. Now, let's see. You see it?
Not yet.
No?
You don't have your screen shared, Paul.
I thought I pushed it here. Okay, let's go back. Oh, now I got this. Oh, now I've got launch meeting here.
You're already launched.
Yeah, that's what I figured. Oh, I
So-
gotta hit, if I hit share this.
Yep,
Oh, okay.
there you go.
Now,
Okay, that we got your screen.
okay,
Yep.
now. Anybody want to guess what it is?
M33.
33.
Yep. Okay. Well, you saw some of my previous images of this object taken with my 115 millimeter refractor, which was also an Astrotech. Well, take a look what we've got, what I've got now in here. You can see that there's a substantial improvement in resolution. The outer parts, the outer halo is coming out much more. You can even see a little bit of detail in here. Some of the, this spiral arm here, which was just barely visible on that previous image. Now here is something too. The same, that the total integration time is the same as with that other object or with that other image. The previous one was 4 8-minute exposures. This is 8 4-minute exposures. And of course, now we have a little more aperture. You can see a lot of the contents, there are probably thousands of individual structures you can see in this galaxy in this image. Once again, I think I pointed these out in the past. These three kind of green nebulas. And these are supposedly H2 regions, but they're greenish. I would have thought they might have been O3, somehow were O3 clouds, because that teal color, in fact, if I enlarge this a little, you can even see some structure in it. You see, now you can see how all the individual star clouds, you can see some of the many H2 regions in through here. You can tell this is probably the most active galaxy in our local group for star formation. This and the Large Magellanic Cloud, which of course you can't see from our part of the world. You got to go down to the southern hemisphere for that. But certainly the most stellar producing galaxy in our local group that's visible from our hemisphere. So anyway, you can see this famous NGC 604. This is like a great big Rosette Nebula. And there's only one other object that's comparable to this, that at least that's in our local group, and that is the Tarantula Nebula in the Large Magellanic Cloud. And if this were placed at the, imagine what this would be like. This object is about magnitude 10.5 at the distance of M33. Imagine how bright it would be if it were at the distance of the Orion Nebula. And it would probably cover about 6 degrees of the sky. I'm going to show you a couple of others here. Let's see, let's get over. Okay, here's the Veil Nebula, taken with my, again, taken with my 6-inch refractor. This is 8 4.5-minute exposures. Or is it 10? It's either 8 or 10. I sometimes forget to, but anyway, look at the, it's took to coax out the colors here. These images were all taken with a modified Canon EOS R camera and some of the basic processing software that Canon offers. This is Canon processing software that this was used with. I used a Deep Sky Stacker to stack the images. So anyway, you can see the filaments come in here. The colors are quite vivid. And of course the star colors, I dare any of you to count the stars on this frame. But the images actually the computer did that. They gave an actual number of stars. I don't know how it was able to do it in such an instant, but anyway, you can see the tassel comes out quite nice. This probably could have come out a little bit more if I made a few more exposures of it, but it took a while. It was an effort because, for one thing, the camera takes the dark frame afterwards, and I wanted to have, and that's partly why you hardly see any noise in here in this image. Let's go over to another one here. Okay, this one, here's a deep shot of the double cluster. So you can see, of course, the main stars and that comprise the cluster. I'll zoom it in here a little bit for you. Here are the star cluster. Notice that this whole part of is an OB association, and it's it's comprised, this whole region here is mostly hot. And by the way, these clusters are a hot item. Note the colors of the stars mostly. And by the way, this cluster here, which is NGC 884, is actually a little further along in its stellar evolution. And these are some class M stars. They went to the red. And these massive stars, as we all know, evolve very quickly. The more massive, the more quickly they evolve and the shorter lived they are. And these have already gone on to their later stages. This is 869 over here, which is all O and B, mainly, and a few A stars. But anyway, you can see that here's the star field. It's when taken through a sizable scope like this, it certainly makes for a spectacular image. These were 20 90-second exposures. So it was a total of 30 minutes of integration time here. And again, taken with the same equipment that the others were taken with. Okay, here's the bubble nebula in Cassiopeia, and the cluster, this is M52 over here. Bring it in a little bit, you can see some detail in the bubble. You can see how this came out. I believe this was 10-4, it was probably 10 4-minute exposures. No, I take that back, 10 4.5-minute exposures that it took, since this is a fairly faint object. So anyway, you can see how the cluster came out. I'll show you. And then here's a real super close up here of the bubble nebula and the surrounding nebulosity. So you can see this 6-inch refractor certainly can pack a wallop, does some damage on these objects. Here's the Orion Nebula. Now this was multiple exposure lengths. Some range from 8 seconds to 4 minutes because of the fact that it has such a wide range of brightness. But you can see finally was able to get some, I was able to bring this outer shroud, this outer arcs out without blowing out the Hygenian region, although it is almost. Didn't quite get the trapezium, which would have been right here. Then the Running Man Nebula really comes out fantastic. You even got some of the outer, the outer field here. This is not entirely dark around here. So you can, some of the outer nebulosity showed up here. And here this cloud is right in front of the other nebulas. This was something that never showed on a, almost never showed on a photograph that was taken with film or with photographic, chemical emulsion. Never was able to, never had the latitude to pull this up, the dynamic range. So anyway, these are some of the, this is what I've been doing lately with my 6-inch refractor. And so those are some of the first images. These were all taken out at CAC.
Those are great images, Paul. It looks like the, are those cropped at all, or are those the full frame of your Canon camera?
This one is full frame. This one here, yeah. This is a full frame. Here it is. Now,
it looks like you have good star quality all the way out into the corners.
Oh, absolutely. See, this was used, this is an Astrotech. They put out a supposedly a field flattener that's specifically designed for use with that scope, but they never have it available. They keep saying more on the way, more on the way, more on the way, more on the way, but it's never. So I was able to snatch up a William Optics reducer lens, which this is I'm using with this, and sometimes it's tricky. You don't know if it's going to work or not. You know, when you get something mixing brands, sometimes it's a little bit of a, you know, it's kind of a crapshoot.
It looks like the spacing and everything you've got here works pretty good, so don't change anything.
Spacing, what do you mean?
Well, a lot of times you have to adjust the spacing to get just the right distance between.
Oh, I see what you, yeah. Well, it had a scale on there. And then I looked it up where I bought it from. They had a list of settings for different optical dimensions. See, that's the thing, because that thing is adjustable, whereas some of these other field flatteners are fixed, and they come, so when you screw them in, they're automatically properly positioned. But otherwise, yes, the images I thought might be, when you blow them way up, they get a little bit soft, but I don't know if that might be just as good as the resolution that the scope will give you. This is a triplet lens, by the way, this 6-inch refractor, but this is the full frame. Now those others were cropped to fit the format of some of them are on display on the big screen out at CAC. And then of course, Doug Summers knows all about this because I had to send it to him. And then he had recommended formatting it for, 9:16, frame ratio. Whereas this full frame here is a 3:2. This is like a original 35 millimeter format that these images all started with. But yes, yeah, I wouldn't want to mess with that, the positioning of that. I don't know if it's kind of, if it ain't broke, don't fix it,
Right. Okay, well, thanks for sharing those.
Yeah, well, I kind of thought somebody might, yeah, and of course, if anybody has any suggestions or anything, how I can improve on them. I'm just starting on my, oh no, not that one there. I'm also starting on Hickson's site. I just downloaded it and purchased it. So if anybody uses it, I could possibly use some help with it. and those images are going to be, as a matter of fact, here's a sample taken with my, now this was taken with my ASI 2600 camera from ZWO Optics. And here's M81. This is a 2-minute exposure with that same scope and field flattener, M81 and 82. Look at the detail. Now imagine stacking 40 of these.
We'll be waiting.
Yeah, I have to master it first. This is the raw image. It's unprocessed. I'm just using it, Hickson's site, to be able to view the thing, and I have to stretch it to get it out of linear there, because all you'll see is just a couple of the brightest stars in it. So anyway, here's M81 and 82. I would say it shows some promise, wouldn't you?
Look nice, Paul. Thank you.
So that's it.
All right, thank you.
Mhm.
Any other questions, or any other folks have stuff that they want to share?
I have one small question for you, Greg. I'm fairly new. Do you guys have any kind of like data sharing, like grouping images together. Because there is a way in PixInsight. I know we all have different size scopes, different cameras, but in PixInsight, you can go ahead and put these images together and stretch them to fit each other in PixInsight. So I don't know if you guys had any kind of data sharing, sharing subs between each other.
I think some folks do, not everyone, but there may be some who do.
Yeah, this is Brian here. I got a question to do with the filters. You guys somebody, I don't remember who it was, just put out a picture of the Heart Nebula with it looks like it's using some kind of filter versus just being all red. What was the filter? If you remember seeing the email on it.
Is that you, Randy?
Gonna have to go back and look, huh?
Maybe, I think Randy was with us. Maybe he's not with us any longer. I think Randy Smith probably posted that. It was a starless image.
Well, probably because it was filled full frame. Yeah, pretty much. Now the tadpole, the tadpole had a lot of the same colors also. I mean, I know when you look at it in stellarium and you explode the tadpole, it looks like that. But if I were to take a picture of it with my camera, it wouldn't look like that, you know, after I process it.
No, I'm pretty sure he was using narrowband filters for that.
Now, is that just something you could pick up over at the Starzona or something?
If you have a lot of money, yeah.
Oh, they cost that much, huh?
They're very
the good ones
expensive.
do. You know, what you get are hydrogen alpha, oxygen, and what's the S stand for? Sulfur. And so you then you take images through those three filters, but then you map those two in one fashion or another to RGB in whatever imaging program you're using. So that's where the strange colors come from, but it's just because of the mapping that's being used to map those particular filtered images to RGB.
Okay, yeah, because most of mine turn out usually red. I mean, obviously Orion came out with a lot of colors. Some got a lot of good colors, others don't.
Well, most of those nebula are emission nebula, and those are usually red. If you have a hydrogen alpha filter, then you can really pull out the red. But even if you're just using red, green, and blue, or even a one-shot color camera, you're going to see a lot of red in an emission nebula, like the Orion Nebula or one of those.
Yeah.
So the big bonus to using the narrowband filters is that they pretty much block out everything except those narrow bandwidths of color, so that you can shoot when the moon is full or when you're in a light polluted suburban environment, and you can get some pretty dramatic images without being at a dark sky site. And so a lot of imagers opt to do that because it allows them to image from their backyard.
Yeah, well, one thing I in the future am considering getting one of those filters and then imaging, doing the narrowband stuff in my backyard, and then taking a separate set of images out of CAC or out of the dark site in white light and combining them. And I wondered that way it would kind of balance the color a little bit, and then you would also at the same time it would bring out the nebulosity, because sometimes, as you might have noticed, even in my images, some of the stars, like that Veil Nebula image I showed you, the stars tend to drown it out. And with the combination of maybe one set of images in white light and one with filtered, and then, you know, being able to do the filtered images, I wouldn't have to go to a dark site for. And then I would only have to do it for my white light work. Of course, this wouldn't work for galaxies. That you have this strictly white light.
Well, not necessarily. You can shoot hydrogen alpha of the Triangulum galaxy, and it'll bring out, even more so than the image you showed, all of those emission areas
Yeah, well, the galaxies that contain those, like M33, the two pinwheels, M33 and M101. And still, it would be best, I would suspect that it would be best combine a white light and a filter or a set of each images, stack the whole works together and see what happens.
Yeah, what a lot of folks do is they use the red, green, and blue for the star images, and then the narrowband filters for the nebulosity, and that gives you a nice, pleasing result.
Yeah, well, I'm not set up to do RGB. I'm strictly one-shot color. I'm strictly CMOS. One-shot color is what I work with.
Tom, do you have something you were going to show?
I have to go get a thumb drive. I'll be right back.
Brian, did that answer your question?
Well, yeah, basically, I think just basically it sounds like, I mean, I'm using CMOS, so just, I've got one of those ASIs, the 294. And basically it sounds like if I wanted to do it, put a hydrogen alpha on there too and take pictures with it. And that'll probably clear it up some.
You have the one-shot color?
Yeah.
Yeah, you can put a hydrogen alpha filter in front of it, but it reduces the amount of signal that gets through a lot. So you're only collecting data with the red sensors. But
Yeah, you've disabled the others.
I wish Randy was still on, because he has several different filters that he's been using with the one-shot color, and getting some really remarkable results.
Greg, I can speak to that because he was giving me advice. He just sent me to Starzone. He said, get yourself the Optilong L-enhanced filter. I think he may also have the L-Extreme, which is very narrow bandpass. The L-enhance is hydrogen alpha, hydrogen beta, and O3, right? And then the L-Pro is more of a light pollution filter that still provides some benefit.
And those are pretty reasonably priced filters, I believe, in the $200 to $400 range.
Yeah, the Pro and the Enhance reach about 200. The Extremes over 3.
Well, it sounds like I've already got the hydrogen alpha then. Didn't realize that because I've got the L-enhance.
Oh, yeah.
Worth a try.
Well, that's when I get my telescope back. Yeah.
What was that? Got your telescope. What happened to it?
Glass broke. Well, yes.
What kind of scope?
9 1/4.
Oh, what happened? Oh, you mean the corrector plate?
Yeah.
How'd that happen?
Bad knees.
Pardon? Oh.
Bad knees.
Oh, you mean you fell with it?
Yeah.
Oh gosh.
Ouch.
Yes.
Okay, guys. Brian, you were talking about in the different colors. This is the Heart Nebula I took out at CAC, and I used the L-Extreme filter. This is on a C8, an older C8, and I processed this using Maximum DL, and I got a pretty good range of color.
Yeah.
Now, what does the L-Extreme got? I mean, what's the difference between that and like the L-enhance?
It's just a little bit more sensitive. I'm pretty sure that was, I may have misspoke. I'm pretty sure that was an L-enhanced filter. And I got this lovely image, and this is 22-minute exposures using a ASI 533 camera on a C8.
Okay, so these were.
Can you zoom out on that?
Okay, can you repeat that about the exposures? They were 22
minute exposures. No, that's let's see if I can.
40 minutes of exposure altogether?
Yeah, that's 40 minutes.
Yeah. So 2 minutes, not 22 minutes, careful, that's.
20 at 2 minutes.
Okay, all right, yeah.
It's 40 minutes total exposure.
That's
Integration
great.
time is 40 minutes.
That's impressive.
Yeah. Okay,
And,
so, and this is a C8 working at what? Or were you using a hyperstar on that?
Yep, this is C8 with a hyperstar, so it's about 400 millimeter.
Okay.
How did you get the green and blue to come out? Because I've been using a IDAS NBZ trying to do exactly what you have there, and I've got a hyperstar on a C8, and I can't draw out the green and blue.
One of the things that I did was on the very first thing I do in my processing is color balance. There's a section in the processing of Maxim that you balance the colors so that you get a properly weighted color image.
Yeah.
And I have had really excellent results with that.
I use AstroPixel processor, and I'm not sure that that's in there as a kind of an initial step.
Yeah, it's the very first thing that I do, because if you do it later on, you get really weird,
Yeah.
really strange effects. So you stack the image, and then the very next thing I do is I do a color balance.
So in other words, the order in which you do those steps is critical then, huh?
It can make a big difference in your image, yes.
Okay. Wow, that is quite impressive though.
That's at 25%.
You probably could have done that.
This is full frame.
Yeah. Okay. Yeah, that I know about that camera. I one time considered getting it, and then I decided to get the 2600, which is a much bigger sensor.
Yeah. The interesting thing about this camera, one of the things I really love about it, is it's backlit.
Yeah, so's the 2600.
And that really reduces the noise and stuff.
Oh yeah.
And it increases the detail. But I was really amazed that these images came out this well.
Yeah.
I really was very happy with it.
And in this particular one was with the L Extreme, right?
Yes. And the camera is a 533 ASI, ZWO 533.
Yeah.
So just a point of information, I took a quick look, and that L Extreme filter is a 7 nanometer HA and O3. So if you figure, you're talking about 2% of the light, right, is coming through there, right? You're using from, let's say, 400 nanometers to 700 nanometers. That's 300 nanometers, and if you've got a 7 nanometer filter, okay, you're getting about 2% light through that filter. So that gives you kind of an idea about why you have to have a longer exposure.
Yeah, well, I mean, I'm surprised. Yeah, of course, that wasn't too bad. You were able to pull that off in 40 minutes.
Yeah, both this one and the okay.
Would you have needed a dark site to get that picture because of the fact that it's so narrow band? You could have done that in your backyard, couldn't you? Could that have saved a trip to CAC?
No, it's I don't get this kind of quality image in my backyard.
No, even with that filter?
Not no.
Okay.
It's part of the quality of this image definitely was the seeing that night was unbelievable. The skies were really, really clear. The very stable evening. It was one of those serendipity kind of things that you get once in a while. And I think this might be a single. Okay. And this is the Sol Nebula,
Oh, okay.
taken the same night. So I did the heart and the soul on the same night, and it was just one of those very serendipitous kind of things that you happen to get every once in a while. Yeah, if you go up past full frame, you can see it degrades a little bit, but
Yeah.
the dark images and the dark sections of both of these nebulas really came out well.
Yeah. Looks like it got some Bach globules in there, like
Yeah.
a meat.
Anyway, I thought I would, and those were using the L Extreme filter.
Good examples. All right. Well, we're about at an hour and a half, so I'm going to try and end the recording here so it doesn't end up being too long to upload to YouTube. So again, our next meeting will be January 17th, and the Zoom address should be the same as they used tonight, but of course I'll send out a link to it and some reminders, and hope to see all of you on the 17th. Have a good holiday.
Same to you.
Same to you. Bye, guys.
Bye.
Bye.